Okay, how many points are always collinear? How many points are always coplanar? What's the vertex of angle ABC? B. What are the sides? Sides are points? Ooh. Let's draw the angle. What letter do I put at the vertex? And then I put my other points on the other sides. So you want to tell me again what the sides of my angle are? BA and BC. Why does it have to start with B? Because it's the vertex. It is the end point of your ray. Has to be rays, has to start with B, has to have a ray symbol over the top. Are ray AC and ray CA opposite rays? No, why not? Perfect. Not the same endpoint. What are the opposite rays in that picture? BC and BA. Perfect. All right, so next one, we want to find x, knowing that the measure of two complementary angles are 3x plus 4 and 5x plus 6. What does complementary mean? Add them together. 90 degrees, absolutely. So what's my equation going to look like? Okay. What do I have to do at that point? Absolutely. How do I know I shouldn't just start subtracting things? Variable on the same side of that wall. That equal sign is your wall. They're on the same side. I need to add them together, not subtract. 8x plus equals 90. Now what do I do? There it is. So 8x is 80. What's x? And that's all it asked me to do. Find x. So then I'm done. All right, number 6, the formulas are in your 1-6 notes for distance. What do I plug in where? What are my x's?
-4 - 6 squared.
Okay, because those are, x is your first letter. Ooh, what are my y's? Okay, so you got to make sure you keep your x's with your x's, your y's with your y's. Go to separate points to get those values that you're plugging in. All right. When I get this first one, -4 - 6, what kind of number do I get? Absolutely. When you type that in your calculator, you have to have the parentheses around the -10. If you do not, your calculator is going to give you back -100. But what's a negative times a negative? A positive. If you don't have the parentheses, it doesn't give you back a positive. It takes 10 times 10 and then takes the opposite of it. You want it to take -10 times -10, so you have to tell it that. You have to tell it the whole thing that's getting multiplied by itself is -10. The other one, what are we at? 7? Does it matter if I put parentheses around the 7? No. But if you're a person that's like, I don't know when I should use parentheses and when I shouldn't, just use parentheses all the time. Because if you put 7 in parentheses, it's not going to hurt anything. Your calculator is still going to be able to do it. All right, what do we get then? You can either give me what that is total, you can give me the next step. I don't care. Where are we at? And then you round that to the third decimal spot, the thousands, which is? Agreed. You should be able to type that all on your calculator at one time. I need one step in between plugging the numbers in and getting to that final answer. I don't care what that step might be. Could be the 100 plus 49 to get to 149. It could just be giving me 149. I just need something in between here and there to know what you did in the calculator. Does that make sense? Okay. Midpoint formula, what do we add together? Okay. So you put your x's with your x's, you put your y's with your y's. Same as the last one, except the last one we subtracted. This time we're adding because we're trying to find the middle. We're trying to average them out. So you add your numbers together, divide by 2. So what is that as a point? Okay. Could you write that 3/2 as 1.5? Absolutely. So I don't care if you leave it as a decimal fraction, doesn't matter. Questions on those? All right, if you have not yet tried the ACT, you should be trying it right now. You should be putting in an answer for the ACT. Try something. All right, I had some J's out there, some K's out there, some G's out there. So we have a rabbit farm. She used the expression 200 times 1.5 to the 0.5 t that models her farm's rabbit population after t years. According to the model, what will her farm's rabbit population be in 4 years? Is there one you can eliminate right away? Which one? Probably 300. That's a little low, right? Because even if I did 200 times 1.5, that's as if it's done no time whatsoever. So I can cross that 300 out. What's the math skill they're trying to get you to do? It's not super mathy. It's typing in your calculator. It's can you figure out how to type this in? What is our t value according to what's in the problem? I'm seeing a 4 out there. Because it wants to know 4 years. And they told you t years. So what this is asking you to be able to do is type this in your calculator. But here's the deal. Depending on your calculator, that exponent could need parentheses. Majority of what I'm seeing out there right now are scientific calculators. You need parentheses around it. You need this to be grouped together. So either you have to take 0.5 times your 4 first and then type that in that spot, or you have to put parentheses around the 0.5 and the 4, because otherwise it'll take 1.5 to the 0.5, take that answer times 4. Because order of operations, it's going to do the exponent first, then it's going to do multiplication and division. So if you don't tell it to do those together, it won't. So you got to check your calculator for how you got to type it in. What do we get when we do that? 450. So it should be G. If you had one of those other answers, my guess is you needed the parentheses when you typed it in. So double check it on your calculator to make sure you can get 450. When it's 100% right, you've shown work on 5, you've shown work on 6, you made sure there's ray symbols on number 3, and you gave me some work on that ACT. You're going to put your name on it, and you're going to pass it in. Don't have a calculator out right now. Get one. What we're looking at today is areas and perimeters. This is stuff you've done before. Perimeter is the sum of the lengths of all the sides, so we add up all the way around. When you were in middle school, they probably gave you formulas for it, and we'll talk about those formulas. But what you need to recognize is perimeter is just adding up all the way around. So you may not always have a shape that has a formula, but you can still find the perimeter because it's just going around the outside of it. Area is the number of squares on the inside. It's how much space it covers. So right now, I would like you to find the perimeter and the area of those 3 rectangles that are on your paper. You can talk to the people at your table about it as you're doing it, but you're finding perimeter, distance around, and area of those. how I get perimeter? Come squares around the outside. So how many squares are on this outside? No. How many squares are right here? 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 Anybody want to change their answer on their sheet? Oh, distance around the outside. You got to check every piece of it around the outside. So what is our perimeter? 20. What's our area? 16, because then I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So then we're counting up how many boxes are on the inside. See if that changes your answer on the next one before I ask for perimeter. So I'm going to just pause for a second and let you recount. Because we added 2 plus 8 plus 2 plus 8. We went around the outside. All right, so now what do we have for a perimeter? 16, because we're adding 3 plus 5 plus 3 plus 5. What's 15? How about the last one? 16 for which? Perimeter, because we have 4 plus 4 plus 4 plus 4. What do we got for area? Area. 16. Okay, so do rectangles with equal perimeters have the same area? Looking at this, I got equal perimeters right there. Do they have the same area? 9. All right. Do rectangles with equal areas have the same perimeters? Probably not, or not? No, because we got equal areas with the first and the third, but they don't have the same perimeter. So you have to recognize for everything, you actually have to count up around the outside to find out your perimeter. Add up all the sides to get perimeter. Area formulas, we're going to talk about a couple of them that we'll work with this chapter. Good? All right, so we have rectangle. You did get formulas for the perimeter back in middle school and elementary school. How do I find the perimeter of a rectangle? Multiply what? If I'm doing side by length, that's finding the area. So using my picture here, that'd be base times height. What times 2? Absolutely. We got to take each of these times 2. Add them together after we multiply the sides by 2. But again, I'm not going to ask you to memorize 2b plus 2h. I'm going to ask you to memorize the perimeters adding up all the sides. Because that formula only works for a rectangle. Add up all the sides works for any shape that I give you. All right, what about circumference on a circle? What's our formula for that? There is an r in it, absolutely. What else is in it? There's a pi. Okay, pi r squared is actually the area. So we got pi r squared area. What's our formula for circumference? It is not radius plus radius because that won't give me the distance around. Circumference is all the way around this spot. Uses all the same numbers, just in a different order. 2 pi r. But if I put 2 radii together, what does that give me? The diameter. So some people will look at it as pi times diameter, and those mean exactly the same thing. Because 2 radii is a diameter. What's pi? That's 1/4, and then there's more after it, right? We always round to the thousandths in here, so we are going to round to the 2. But when you are doing problems with pi in it, you are not going to round it all. You are going to use the pi button on your calculator. do not type in your calculator 3.142. You are going to use the pi button on your calculator. Well, what's the number after the 1 when you go 3.14? Then if the number after the 1 is a 5, what do you do when you round? Re-round up. So that's why I have it rounded to 3.142. But again, you're using your calculator's pi button. That's just to remind us all what pi is. All right, when we label for perimeter, we label it in whatever units our sides are in, like feet or centimeters or inches. Whatever we have measured everything in, that's the same label. But when we label for area, what do we do to those? It's not just feet, it's feet what? There it is. Or centimeters squared or inches squared, etc. It's one, you have to have the squared in there when you're dealing with area. All right, so on the next page, my pool is 15 feet wide and 20 feet long with a 3-foot wide deck surrounding it. And you want to build a fence around the deck. How much fencing would I need? What am I talking about? Area or perimeter? Why is it perimeter? You're right. Absolutely. The fence is going around the deck. We're not covering up the pool with the fence. That would make the pool not usable. So we're going to put the fence around it. Okay. Thoughts on how we should attack this problem? Things that would make it easier. Yeah. What formula? Okay, so since it's a rectangle, we'll be doing 2b plus 2h. Absolutely. Do we know what rectangle we're doing the perimeter up? Okay, so we're putting the fence right around the pool. Yes? I'm seeing some head shakes. What does it tell me I got to do? I got to put a 3-foot wide deck. Would it be easier if you could see this? So let's draw a picture. I don't care how you make your 15 and your 20. It doesn't matter. But then around that, we are putting a 3-foot wide deck. So I'm adding 3 feet here. I'm adding 3 feet here. Down here gets 3 feet. Over here gets 3 feet. So we got 3 feet going all the way around the pool. So how long is that side? Just 18? Plus 3 again. Good. We got 15 from here to here. But then we got another 3 and another 3. So how much? 21? Okay, what about the other side? 26. Because again, you had 20 from the pool, but then you added 3 on each side of that 20. Okay, so go ahead and find your perimeter. If you're sitting there waiting for somebody else to do the addition for you, that's the wrong choice. You're finding your perimeter. Perimeter is adding up all the sides, or you can use your rectangle formula. Sensing some confusion. What are we adding right now? 26 and 26. And 21 and 21. You're adding up all 4 sides. If you're using the rectangle formula we talked about, you could have taken 2 times 26 and 2 times 21. Either way, what do we get? 94 what? Did we find area? So what's just feet? Square feet's when we find area. All right, are there questions on how we got the 21 and the 26? Great, then you're on the next problem where it says you try. Go. we got for a perimeter of the picture? 26 inches. I heard from 2 different people. Are we okay on the 26 inches? Okay, what I'm seeing is confusion on where numbers are coming from. So if this is 6 by 7 in there, the perimeter is 6 plus 6 plus 7 plus 7, right? Now I'm adding a frame outside of it. So when I look at this bottom side, I know that it was 7 originally on the picture. And now I'm putting a 1/2 inch frame around it, so I have a 1/2 inch on each end of that 7. That gives me a total of 8, because you add them all together. Same thing's going to happen over here. My 6 inches from the picture is still there, but now I'm putting a 1/2 inch frame on top of it and on the bottom of it because the frame's going all the way around the picture. So how long is this side? So now what's my perimeter? 30 inches. So this one we were adding 6 and 6 and 7 and 7. This one we're adding 7 and 7 and 8 and 8. Is that okay? All right, now we're going to move on from rectangles and go to some circles. We have 2 different words that we've got going on here, and one is exact and the other is approximate. When we are finding exact circumference, you are going to leave the pi symbol, which means you will not type the pi button on your calculator. You will just leave it with pi in the answer. When it is approximate, you will type the pi button on your calculator. Because the calculator has to round pi. Pi goes on forever. So even though the calculator is got more decimals in it than we could use, it still is rounded somewhere. So it's an approximate answer. Formula for circumference we said on the front page was 2 pi r. What's our r? 6. Nice. You had the diameter there. Radius is just half of it. So I need to do 2 times pi times 6. If I'm doing exact, I don't type the pi in my calculator. What's 2 times 6? 2 times 6? 12. Sorry, I heard a 30 something. And circumference is like perimeter, so we leave it with just inches as its label. If I'm doing circumference, or sorry, exact, I leave the pi. Approximate, I type the pi in the calculator. So now you're using your calculator to type that same formula in. You're picking up the calculator and you're typing. We are rounding to the 3rd decimal place. I've got 37.699. 699. We're good? Okay. So 37.699 inches. Are we okay on the rounding? What's my 4th spot? 4th number? 0.6991. So that is why that 9 stayed the same, because the 4th decimal spot was a 1, so we don't round up, we leave it the same. Yeah. On the graphing calculator, the pi button is, you do 2nd and the caret key, which is right above the division symbol. Yep. All right, so exact area, we don't type it the pi in our calculator still. So area is pi r squared. What did we say our radius was? So pi 6 squared. Don't type the pi in, just do the 6 squared part. So we get 36 pi inches squared because it's area. Then when I do it as approximate, you type it in the calculator. You got Do we have agreement on the rounding? 097. Yes? Okay. I need a label on it then. Inches squared. Now, when we get to the test on this chapter and you come up and ask me which one's exact and which one's approximate, I'm not going to tell you. You have to know exact is with the pi symbol. Approximate is typing it in your calculator because you are obviously rounding when you put it in your calculator. That's why it's approximate. All right, at tables, do the bottom one. Double checking with the people at your table. All right, what do we have for an exact circumference with this radius of 18 meters? 36 pi meters. Good. Because we took 2 times the 18 to get that 36, right? All right, what about the approximate? Or meters. All right, what about the exact area? Does everybody agree with 324 meters squared? Pi's got to be in there. 324 pi meters squared. Where did the 324 come from? 18 squared. Good. Okay, what is that as a decimal? Well, there was a lot of just like interrupting there. That's kind of rude. 1017.876 meters squared. Are we good? Okay. Next page. We are going to graph those points, and then we're going to find the perimeter. When we graph -3, -3, where do I go? I'm at 0, 0. Where do I go? I go left 3, down 3. Okay, so 1, -3, I go right 1, down 3. Points. Right and left first, up and down second. So 1, 4, I go right 1, up 4. Left 3, up 1. And then I trace in my picture. If I want to find the perimeter of this shape, what do I need to know? The distance. I need to know how long the sides are. Are there sides on here that are pretty easy to count? Which ones can we just count? Which sides can I just count? Okay, so the 1, 4, and 1, -3, I can just count how long that side is. How long is it? Yep, you're up 4 and you're down 3. That's a total of 7. Give me another side I can just count. The bottom. How long's that bottom? 4. Okay, one more side I can just count. The left side, how long's that one? Okay, so I've got 4, I've got 4, I've got 7. I can't just count that slanty side though. So I have the distance formula there for you. How do I know which points to put in the distance formula? Okay. Because -3, 1 is that one. 1, 4 is that one. So the ends of the slanty sides are what we're going to put in that distance formula. So the ends of that slanty side are what you put in your distance formula. All right, for the sake of time, I'm going to plug the numbers in for you. We got 1 minus -3 squared and 4 minus 1 squared. 1 minus a -3 is 4. What's 4 squared? Okay. 4 minus 1 is 3. What's 3 squared? 16 and 9. Square root of that is? I heard 5. How do I get the perimeter of that shape? How do I find perimeter of anything? Add up all the sides. So we got 5 plus 4 plus 4 plus 7 for a total of? Yes? So our perimeter at 20. All right. When we deal with measurements like this, we have to be able to convert between different forms of measurement, which is what's happening in the next part of that sheet. Are we okay here before I switch? All right. 1 foot. What do we know about 1 foot? 12 inches. 1 yard. 1 mile. Nice. There is another conversion. This one might not be as well known as the 5280. If I wanted it in yards, it is 1760. So 1,760 yards is the same as 1 mile as well. The top three are the ones to remember because you can get the yards one from the feet one. And since I got a bunch of people saying the feet one, that one might be one that's more readily known at this point. The other thing we have is the metric system. The metric system is based off a power of 10, right? So when I have these, I have the first letter of all of the prefixes. So K for kilo, hecta, deca, base. B is for base. Why do I put a B there? Because it could be meters, it could be liters, it could be grams. So any one of those metric options, that B in the middle is for base. Then I've got deci, centi, milli. I remember those letters with a phrase. Some people just memorize the order of the letters. I remember it with knights hate dragons because dragons chase men. And that just helps me remember what letters to write down because knights is a K, hate is an H, dragons is a D, because B, dragons, D, chase, C, men, M. It's just a mnemonic phrase to kind of just help you remember the letters. But what you need to know about this is it's powers of 10. So if I am trying to go to the right, so I'm starting over here on the left and I want to go to the right, I multiply by 10 for each letter. If I am going to the left, I am dividing by 10 for each letter. You have also learned it as moving the decimal point because our numeric system is based in base 10, right? So you have tenths, you have thousandths, you have hundredths, all those. That's all either multiplying or dividing by 10. So if I want to go from 3 meters into centimeters, when I look at that same phrase, knights hate dragons because dragons chase men, this M is where? Where is meters? No, that is millimeters. Base is meters. I'm trying to get to centimeters. That means I need to multiply by 10 and by 10 again because I'm trying to get to centimeters. So when I multiply by 10 and then by 10 again, what do I get? Take 3 times 10 times 10. 300 centimeters. All right. If I go to the next ones, knights hate dragons because dragons chase men. I am going from kilometers to meters. Where's kilometers in my list of letters? The first one. Where's meters in my list of letters? No, the last one is millimeters. Meters is a base. So how many times do I have to multiply by 10 since I'm going to the right? You got to multiply by 10 3 times. What do I get when I multiply by 10 3 times? So it's taking the 5 times 10 times 10 times 10. Multiply by 10 for each letter you're moving over. All right. Knights hate dragons because dragons chase men, and I'm going from meters to millimeters. Where's meters? Base. So I'm here at the base. Where's millimeters? The M at the end. So I got to multiply by 10 how many times? 3 of them. So I got 15,000. Does that make sense? Okay. What if I'm changing 12 yards into feet? How'd you do that? 12 times 3. I'm going to put it up here with something called dimensional analysis. I need you to just understand that you have to take 12 times 3. As we go forward in the year, we'll do this fraction work later on. The yards, because there's 1 yard for every 3 feet, we'd cross off the yards. Yes, you get 36. All right, what about 4 miles? How am I going to change that into feet? There you go. And again, I'm writing up the dimensional analysis. You don't have to write it. You need to understand that you got to multiply by the 5,280 because each one of those miles has 5,280 feet in it. What do we get for a total then? that okay? All right, so I have 20 feet and I want to change it into inches. 20 times 12, because in every foot, there are 12 inches, which allows my feet to cross off 240 inches. Okay, those are basic conversions. I do expect that you know how many feet are in a mile, how many inches are in a foot, how many feet in a yard, those basic ones, and I expect you to be able to manipulate the metric system. Why do I need that? Because we're going to go to the next page where we have problems like you are designing a rectangular banner and the banner will be 4 feet wide and 7 yards high. How much material do we need? Well, first of all, what are we dealing with? Are we dealing with area or perimeter? Area. Because I'm not going to buy just the outside edge of the banner. I got to buy all the material of the banner. But can I find area if I've got 4 feet and 7 yards? No. So what do we have to do? Convert it. Convert what? The 7 yards into feet. Always take the bigger unit, change it to the smaller unit. So yards go into feet. How am I changing yards into feet? So we got 21 feet. And then what do you want me to do with that? Absolutely, because we said we were finding area. Area is base times height. So 21 times 4, how much material do I need? 84 what? Really? There it is. You got to have that label. 84 feet squared. Okay, we went through that one kind of fast. Well, I'm glad you like it. Are we okay with what we did there? Area, because we're looking for how much material. And then my labels are different. One's in yards, one's in feet. I took the yards because that's the bigger unit, and I changed it into the smaller one. I changed it into feet. Then I can find the area. You can't find area unless you have the same labels on them. Which leads us to the next one, where it's the area. Find the area of a rectangle with a length of 75 centimeters and a width of 2 meters. Why don't you try that on your paper first before we say it out loud? If people are sitting there wondering which one to convert, which one should we change? The largest one. So the 75? No, the largest one what? Label? Unit? Unit. So the meters is the bigger label, right? The bigger unit? That's the one you need to change. Convert the 2 meters into centimeters. Check it with somebody at your table, see what they got for converting and then finding the area. All right, so what am I doing to change that 2 meters? In centimeters. What do I have to multiply by? Why do I have to multiply by 100? Perfect. We're at the base. We're moving over to the centimeters. So times 10 times 10. All right, then it asked me to find the area of the rectangle. What do you do? I heard 15,000. Somebody else tell me how you got 15,000. There you go. 200 times 75. What label should I put on that? Nice. Centimeters squared. Make sure you pay attention to what you changed it to so you use the right label. That was perfect. Good? Okay, I think you can do the next one without me leading you through it. Go ahead and do the next one. All right. The rectangle is 10 centimeters wide. Its area is 160 centimeters squared. Labels are the same, right? So I don't need to worry about changing any labels. How long is it? How'd you get 16 centimeters? Perfect. Why did she divide by 10? Perfect. When you are looking for area, we knew this one was 10. We got to figure out 10 times what to give you the 160. So we have to undo that multiplication because you would take 16 times 10 to get that. All right, the next one. The perimeter of the rectangle is 20. What does that mean? What's perimeter? All the outside is 20. The base is 6, and we want to find the area. All right, so I got a rectangle. I'm going to make it look more rectangular. I know the base is 6. What else do I know? I know the perimeter. I know all the way around the outside. I was going to make a circle for it, is 20. Do I know anything else about the rectangle? I think I do. It's a rectangle. What do we know about sides in a rectangle? They're not all the same. 2 are the same. Do I know something more? There are 90-degree angles, absolutely. Do I know something else I could put on my picture besides the 90s? All right, so I know that one also has to be 6, right? And these two are going to have to total, all 4 of them are going to add up to 20, but we know those two have to be the same. 4s? How come they're 4s? Okay, 6 and 6 is 12. So that's used up, right? That's used up part of my perimeter. My total perimeter is 20. So if I subtract out that 12, that's where the 8 came from that they talked about. But now I got to split it equally. So we have 4 for each of those sides. Did I answer the question it was asking me? What do I have to do to answer the question? Why? All right. Somebody else tell me what's my area. Nice. You can keep saying it too, even when I say nice, because I like validation. 24 centimeters squared is correct. All right, one last one. You have a square and a rectangle with equal areas. Before I go there, I just want to walk through that last one more time because I feel like we went fast once I had people giving me stuff. We knew the total was 20 all the way around. We had one side. How did I get the second side? Because what do you know about opposite sides? They're the same. So if I knew that one was 6, the top had to be 6 as well. Then I said, okay, 12 is used up out of my perimeter already. 20 all the way around, but I know 12 is gone. So what's left for the other two is the 8, and then I had to split it equally to get the 4 for each one. Then we had to find area. Is that okay? All right, now we're back on this one. The square and the rectangle have equal areas. The rectangle is 25 by 16 centimeters, and I want the perimeter of the square. It's a lot of steps here. I'm going to draw a picture. I have a square. I'm going to do my rectangle first. I have a rectangle because I know things about the rectangle. I know it's 25 by 16. Then I have a square. All I know is that those two have equal areas. And I want to find the perimeter of the square, which means I need a side of the square. Is there something I can find out about the rectangle that might help me know something about the square? What can I calculate? The area. How do I get the area of the rectangle? Is 16 plus 16 plus 25 plus 25 area?
No. 25 times.
All right, so my area, how much is my area? But now do I know something about the square? Yeah, what's its area? What do we know about the rectangle and the square?
Equal areas, so it's the same area.
Okay. What else do I know about squares?
Every side is equal.
Every side is equal. Every side is the same. Do you think we can find the length of that side? 25. I heard 25. How do I find area? How do you find area of a square? What's 25 times 25? Is that 400? No, so they're not 25s. Why is it 20? Because 20 times 20 is 400. Absolutely. So can I get that number if I don't know it off the top of my head? When you take something times itself, like I take x times x, how's that written? X to what power? So if I know x squared is 400, how do I get what x is? I don't think we divide. How do you undo a squared? Find the square root. That's how we're getting a 20 there. But then the question asks for the perimeter, right? Yeah. What do I have to do to finish this problem? There it is. Which gives us a total of? So there's my final answer. So there was a lot of steps in that problem. You had to recognize that the areas were equal. You had to get the area. You had to work backwards to get the side of the square. And then you had to find the perimeter. All right, we have worksheet 1-9 for homework. There are two sides. You will need a calculator. We have 2 more classes before the test day. So if you are having any issues whatsoever, please make sure that you come in for help.